Hey everyone, Neil deGrasse Tyson here, and welcome to a cosmic journey into the eerie silence of space. We're so used to the symphony of sounds here on Earth, from the gentle rustling of leaves to the roar of a rocket launch. But what happens when we venture beyond our planet's cozy atmosphere? Get ready to explore the fascinating ways astronauts communicate in the vacuum of space, where sound, as we know it, ceases to exist. You see, sound needs a medium to travel, like air, water, or even a solid object. Think of it like dropping a pebble in a pond. The ripples, those are sound waves spreading out from the source. Here on Earth, air molecules vibrate, carrying those sound waves to our ears, allowing us to hear the world around us. But in the vast emptiness of space, there's no air, no medium for those sound waves to travel through. It's like trying to have a conversation in a vacuum chamber, an utterly soundless experience. So, how do astronauts chat it up in this soundless void? Imagine being in a place where you can't hear a thing, not even your own voice. Space is a vacuum, which means there's no air to carry sound waves. So, how do they manage to communicate effectively in such an environment? Well, they've got a trusty sidekick: radio waves. These invisible waves are the unsung heroes of space communication. They can travel through the vacuum of space, making it possible for astronauts to stay in touch with each other and with mission control on Earth. Just like the radio stations we tune into here on Earth, astronauts use radios and headsets to stay connected. They speak into their headsets, and their voices are picked up by microphones. This is where the magic begins. Their voices are converted into electromagnetic waves, those invisible signals that zip through space at the speed of light. These waves are part of the electromagnetic spectrum, which includes everything from visible light to X-rays. These radio waves travel to the International Space Station, mission control back on Earth, or even to other astronauts floating around up there. The journey of these waves is fascinating. They can cover vast distances in mere seconds, ensuring that communication is almost instantaneous. Once received, the radio waves are converted back into sound, allowing astronauts to hear each other loud and clear. This conversion process is seamless, making it feel as though they're having a face-to-face conversation, even though they might be miles apart. It's like having a cosmic phone call, minus the annoying drop signals. Thanks to this technology, astronauts can share their experiences, coordinate tasks, and even have a laugh or two, all while floating in the vast expanse of space. Radio communication truly is the lifeline that keeps our space explorers connected. But radio communication isn't just for astronauts. Spacecraft, satellites, and space stations all rely on sophisticated wireless communication systems to stay in touch with Earth. We're talking high-frequency radio signals, the kind that can travel billions of miles across our solar system. NASA's Deep Space Network, a global network of giant antennas, acts like a cosmic telephone switchboard, relaying messages between Earth and distant spacecraft exploring the cosmos. And for even faster data transmission, scientists are exploring the use of lasers, beaming information through the vacuum of space at lightning speeds. Now you might be wondering, what about inside a spacecraft or a space station like the ISS? Can astronauts finally ditch the headsets and have a normal conversation? You bet they can. Inside these marvels of engineering, astronauts enjoy an Earth-like atmosphere complete with breathable air. And where there's air, there's sound. So whether they're sharing a meal, conducting experiments, or just enjoying the view, astronauts can chat, laugh, and even sing karaoke without any high-tech gadgets. It's a little slice of home in the vastness of space. But let's not forget about those noisy situations, even in space. Imagine an astronaut on a spacewalk conducting repairs amidst the roar of machinery. That's where things get really interesting. Some advanced space helmets now feature bone conduction technology, a revolutionary way to transmit sound without using your ears. Instead, vibrations are sent directly through the astronaut's skull to their inner ear, bypassing any external noise. This ensures crystal clear communication, even in the most extreme environments. It's like having a private concert inside your head without disturbing the neighbors. Now, communicating within the vicinity of Earth is one thing, but what about those daring missions venturing further into our solar system? The challenges become exponentially greater as we move away from our home planet. Think about the Moon, Mars, or even Voyager 1. our intrepid probe pushing the boundaries of interstellar space. Each of these missions requires a robust and reliable communication system to send data back to Earth and receive instructions. Here's where the vast distances introduce a new challenge. Time delay. The farther we go, the longer it takes for signals to travel back and forth. This delay can range from a few seconds to several hours depending on the distance. It takes time for radio signals to travel those astronomical distances. For instance, radio waves traveling at the speed of light take about 1.28 seconds to reach the moon, but can take over 20 minutes to reach Mars when the planets are farthest apart. Even at the speed of light, a message from Earth to Mars can take several minutes to arrive, and the reply even longer. This delay makes real-time communication impossible, requiring missions to be highly autonomous. Imagine trying to have a conversation with that kind of lag. It would be like talking to someone on a very slow phone line, where each response takes minutes to come through. This is why astronauts and rovers need to be able to operate independently. To overcome this, scientists rely on powerful space antennas, sophisticated signal processing techniques, and a network of relay satellites. These technologies help to amplify and relay signals across vast distances, ensuring that data can be transmitted and received as efficiently as possible. Additionally, autonomous AI systems play a crucial role. These systems can make decisions on their own without waiting for instructions from Earth. This autonomy is essential for the success of missions that operate far from our planet, where communication delays are significant. It's like sending a text message to the future knowing that the reply might not arrive for a while. This requires careful planning and programming to ensure that missions can continue smoothly, even when direct communication is not possible. The future of space exploration depends on our ability to overcome these communication challenges and push the boundaries of what is possible. As we continue to push the boundaries of space exploration, the future holds incredible potential and challenges. Communication will play an even more critical role in ensuring the success of these missions. Scientists are already working on mind-blowing technologies that sound like something straight out of science fiction. From advanced communication satellites to innovative data transmission methods, the possibilities are endless. Imagine laser communication systems capable of transmitting vast amounts of data at warp speed, or quantum communication, which uses the principles of quantum mechanics to send ultra-secure messages that are impossible to intercept. These technologies could revolutionize how we communicate not just in space, but also here on Earth. Quantum communication, for instance, promises a level of security that could make current encryption methods obsolete. And who knows, maybe one day we'll even develop AI translators capable of deciphering potential alien signals. This could open up entirely new avenues for understanding the universe and our place within it. The future of space communication is brimming with possibilities, promising to connect us across unimaginable distances. Imagine being able to communicate with astronauts on Mars in real time, or even sending messages to distant star systems. The advancements we make today will lay the groundwork for these incredible feats. The exploration of the cosmos is not just about discovering new planets or stars, but also about unlocking the secrets of the universe. With advanced communication technologies, we can share these discoveries with the world, inspiring future generations to continue the quest for knowledge. So there you have it, a glimpse into the silent world of space communication. From radio waves to lasers, bone conduction to AI translators, we've come a long way since the early days of space exploration. As we venture further into the cosmos, communication will continue to be our lifeline, connecting us to those intrepid explorers pushing the boundaries of human ingenuity.